Okay guys, so there's two circles, okay? The first thing you want to do is prove that both circles touch externally. Once again, to pick up a load of marks, I'm going to tell you everything I know about the circle. I'm going to tell you that the G value is 7. I'm going to tell you that the F value is -5. I'm going to tell you that the centre of the circle is -7 plus 5. I'm then going to tell you what the radius is, because the C value is -26. So the radius is, I'll just leave it up here in the corner, G squared plus F squared minus C. G squared being 49, F squared being 25, and minus 26,
25
plus 26. Add them together, you get root 100. The radius is 10. Okay? Go to the next circle, repeat procedure. This time the G value is -2, the F value is 7, and the C value is 28. The centre of the circle is 2 minus 7. Okay? And the radius is going to be equal to 4, because 2 squared is 4. 7 squared? 49 plus 28. And if I'm not mistaken, I think that's going to be 81. Is that right?
Yeah.
And the square root of 81 is? 9. Now let me give you some proof that they touch externally is what we're trying to do here, yeah? So I'm going to give you a bit of perspective here. We have two circles, okay? One of them has a centre at where? -7, 5. Okay, -7, 5 is around here. Would you agree with that?
Yeah.
Then it has a radius of 10, which means it'll go back across the axis. The other one has a centre of 2 minus 7, which will put it down here, and it has a radius of 9. So 2 minus 7, and then what happens is both of them touch each other once. Is that alright with you guys?
Yeah.
Now, the next thing to realise is that the centres of the circle, when they touch each other, I might have to reduce this full picture down in a second. So basically, if you imagine this blue line here, and if you imagine the red dot is the circle, is the centre of the first circle, the green dot is the centre of the second circle, and this purple dot is the point of intersection. Is that okay with you guys?
Is that a midpoint or no?
No, because it won't be a midpoint. Now, I know you're a bit bogey, but basically it's not a midpoint because that distance is 10 and that distance is 9, so it shouldn't be a midpoint. Maybe I just drew it slightly wrong as well. Is that right with you guys? I think the bottom one's too big relative to the top one. Would you agree with that? Okay. So what happens is, would everybody agree that the distance between the green point and the red point should be equal to what?
19.
19. And if they touch externally, the distance between the two centres should equal R1 plus R2. So D equals R1 plus R2 when they touch externally. Does that make sense? Now, how do we find the distance between these 2 points? Well, we have yeah, that's the one.
Easy.
You have -7, 5, and what's the other one? You have 2 minus 7. You have the square root of x2 minus x1 squared plus y2 minus y1 squared. Everybody right with that? Next, x1 y1, x2 y2. So what's x2 minus x1?
21.
2.
16.
2 plus 9. Oh, so 2 plus 7.
That's not 21.
What? No, it's a comma. So 2 plus 7 squared, and then y2 minus y1 minus 7 minus 5. Can anybody tell me what's 9 squared plus minus 12 squared? It's going to be
plus 144.
What is it? 81 plus?
44.
Which is?
221.
225. Okay. I think I might have made a mistake in this, guys. What's the square root of 225?
12.
No, it's...
8.
Stop guessing for this. Huh? 15. Okay. So, do you notice they're not equal to each other? Yeah?
Yeah.
So, I might try and sniff out a mistake here, alright? Let's go back to the top here. Is everybody agree with G being 7 and F being minus 5?
Yeah.
Is everybody agree that G squared is 49? F squared is 25?
So would G not be minus 7 because it goes opposite? Like,
No.
sorry, then you put it in.
Then you put it minus, yeah.
Sorry.
It's alright. Would everybody agree that the C value is minus 26, which then gets converted to?
Plus 26.
And then it's 100. Oh, there it is. It wasn't a plus 28.
Oh, minus within.
It's a minus 28.
We knew it.
Which makes the whole thing. It does seem wrong, didn't it? The 9.
I just feel it in the balance.
25. Which makes the radius 5. So now, unfortunately for me, this diagram is now completely out of whack, so I'm just going to adjust it. So, oh yeah. Then I have to adjust that. Yeah, it's weird. A bit weird now, isn't it? There you go. And 2 minus 7 is still that point there, isn't it? Okay, and we're just going to get rid of that 9. Where's the 9? Okay, so have we proved that they touch externally now? The small one has a radius of 5, the large one has a radius of 10, 10 plus 5, 15, and the both radiuses added together will get us both. The distance between the 2 points is 15, and one of the radius is 10, the other radius is 5. 15 equals 15. They touch
You have to prove
externally.
it.
Yeah. So long story short, get the radius of one circle, get the radius of the, add them together, get the centre of one circle, get the centre of the other circle, get the distance between the 2 points, and if they touch externally, the distance between the 2 points will be both radiuses added together. Now, where it doesn't get so easy is how do you find out what the green, how do you find out what this point here is? Okay? And what we do is we can do this via a translation. Okay, so just stay with me for a minute. Now, would everybody agree that's 10 and that's 5? What is the ratio of 10 is to 5? 2 is to 1. Okay? Now, compare the two centres to each other. Minus 7, 5 and 2 minus 7. Compare them to each other. How many blocks do we need to go down? How many blocks do you need to go down to go from across? How many blocks do you need to go across to go from minus 7 all the way to 2?
9.
You need to go 9 blocks across. Would everybody agree with that? How many blocks down do you need to go from plus 5 all the way down to minus 7? Down 12. Now, what's 2/3 of this distance? Do you understand? The point, the purple point is 2/3 the way over.
Is that going to be 6 and then 9?
6 across,
6 across and 9 down.
9 down from where you started. So what's 6 across?
6
Add 6 onto minus 7,
minus 1.
and then take 6 away from 5.
Minus 1.
Minus 1 is the point of intersection.
Nice.
Where'd you get the 6 across and 9 down?
See the way it's because it's the 9 across 12 down is 3. You add the ratios together to get 3. You only want 2.
Yeah, add them together.
Yeah, you want 2/3 of the distance. See the ratio is 2 is to 1.
Yeah.
That means that the purple dot is 2/3 of the distance
Okay.
between the two of them.
Yeah.
So you just two thirds the distance.
So it's divided by 3.
Yeah. Yeah, and multiply by 2.
Then not 3, 4.
Look, Sean. Divide by 3.
3.
Multiply by 2.
What do you?
Shh. All right. Basically, Sean, what happens is, whatever the ratio is,
Yeah.
add them together.
Okay.
Okay. We get 3 when we add the ratio together.
Yeah.
This means to go from the red point to the green point is the full length,
Okay.
and because it's a ratio of 2:1,
Yeah.
basically the purple point is 2/3 of the distance.
Right.
It's 2 away from the red point for every 1 it's away from the
3.
green point. So you multiply the entire distance by 2/3, which means you multiply the 9 by 2/3 and the 12 by 2/3, and then you add it on to where you started from.
So you divide by 3 and multiply by 2.
Yeah, basically on both of them, right? We try another one out.
So the answer is just 6, 9.
You move. The answer is 6, 9, but you move it across. You move your original center across 6 and down 9. You move that across 6, down 9, and it ends up at the new point here.
Oh, so that's how you find the. Okay, now I get you.
All right. Let's try another one now. Will I do another external one? And then one internal, and then we're done. Okay. Same deal as last time, except I'm going to go a bit quicker between the between parts. All right. So G is 4, F is, C is, center is, radius is
32 minus 20.
16
8.
plus 16 minus 24. Ratio is root 8. Now just be careful with that, because root 8 in your calculator is 2/2. Okay. This is important, guys. Next part. G value, F value, C value. 0. Radius. 1 squared plus minus 1 squared plus 0. Root 2. Okay. Center of the circle is minus 1, 1. Now, if you don't mind, just indulge me for 1 second. I'm going to. So, what I'm going to draw here is an XY axis. We have minus 4, 4, and minus 1, 1. Okay? And it says external, doesn't it? Minus 4, 4, minus 1, 1. Okay, so I'm going to bias it this way here. Now, what's going to happen is the first one has a center of minus 4, 4. 4 across and 4 up. Is that right? 4 across and 4 up. Okay, that's it there. Okay, the other one has a radius of what?
Minus 1, 1.
Minus 1, 1. Okay. Now, I can tell you right now that this one here is basically this size here. Okay? And the other one is this size here. Okay? Now, what I'm basically going to do here is just going to control group this. I'm actually going to have to try and make this a bit bigger now in a second. Group. Now, you can see the diagram's a bit on the small side, so I'm just going to extend it. And there we are there. Everybody alright with that?
Yeah.
Now, to prove that they touch externally, what do I have to do? I have to prove that the gap from the green to the blue
Is equals to the radius added together.
radius added together. Is that right? So the radius added together is 2 root 2 plus a root 2, which is
3 root 2.
3 root 2.
3 root 2.
Now, this is minus 4, 4. This is 1, minus 1, 1. Let's find the distance between both points, okay? It's x2 minus x1, so call that x2, y2. So it's going to be minus 4 plus 1 squared,
4 minus 1.
and 4 minus 1 squared. It's going to be 3 squared plus 3 squared, which is root 18. Root 18 is in fact 3 root 2. External it is. Are we right with that?
Yes.
Now, here comes, that's the easy part, would you agree? The hard part is finding what is the, what's the purple dots. And please be in mind that the purple dot has to be on the line that joins the two centres. Is that alright? So what we say is collinear. The slope from green to purple is the same as the slope from green to blue. Everybody right? That's, you're going to use that very soon. Okay. Now, here's what happens. Sean, we do what is called a ratio first. We do the ratio of the big radius to the small radius. Okay? So we do 2 root 2 ratio root 2. What's the ratio? 2 is to 1. This means that if you take the green to blue distance as the total, the purple dot is 2/3 the distance away. If that was a 3 is to 1 ratio, it'd be 3/4 of the distance away.
You have to go from the green to the blue.
Yeah, and it's 2/3 the distance. If I had a ratio of 4 is to 3, it would be 4/7 of the way away. Does that make sense? 4/7. You add them together, Sean.
Wait.
Sean, add them together.
Yeah. 7.
What's the first number? 4. It's 4/7 of the distance. Add them together. 4. What's the first number? 3. 3/4 of the distance. Add them together. 3. What's the first number? 2. It's 2/3 of the distance away. Now that's that in. How much do you drop? You drop 3 and you go across 3. What's 2/3 of that distance? Across 2 and down 2 and across 2. And you can see I pretty much had the purple point right there, didn't I? I nearly drew it very accurately. So therefore the answer is going to be -2. -2, 2. Is that alright? Alright guys, one more for the road. For the day. Last one. Prove that the circles x squared plus y squared plus 4x plus 6y minus 19 and this other guy touch internally and find their point of contact. Now, internally, let's find out what the difference is between external and internal. Just going to draw a quick diagram for you. We'll figure it out from there. G value is 2, F value is 3, C value is minus 19. Centre is -2 minus 3. Radius is G squared 4, F squared 9 plus 19. Is that root 32? Root 32, which is 4 root 2. Up to the next one. G is -1. The F value, non-existent. The C value, -1. Next. 1, 0. The radius, 1 squared is 1. F, 0, minus 1. Radius is root 2. Everybody happy enough with that?
Yeah.
Now, I want to draw the two of these out for you. Okay, and just want a quick diagram of them. So, the first one has a centre of -2, 3. -2, -3. And it has a radius of 4 root 2. Now you guys won't be able to do this, but I know roughly how long 4 root 2 is. 4 across, wait, 4 across and 4 up. That's it there. 1, 2, 3, 4. 1, 2, 3, 4. That point there, right? That's a rough radius of 4 root 2. Okay. What about the other one? It has a centre of 1, 0, which is in here, and it has a radius of root 2. Root 2 is actually 1 across and 1 up, because if you do Pythagoras' theorem, that's root 2. That's how I knew 4 root 2 was 4 times bigger. So I went 4 across and 4 up to measure that. Now, either way, you don't need to be that advanced, but what we have is you have an internal You have an internal circle. That's the difference between external and internal. Now, if this is the green, if this distance here, I'll do it by line, and they both touch at the, would you agree they both touch at the purple point? That makes sense? Now, if the distance from here to here is 4 root 2, what's the distance from here to here?
2. Oh, root 2.
Root 2. And therefore, what should be the distance from centre to centre?
3 root 2.
3 root 2. So this time it was actually R2 minus R1.
So you just minus.
The differences in the radiuses.
You minus the bigger one.
Yeah. Now, I'm not going to do this one out for you because I think you're getting a bit impatient with regards to time. But what you can do here, guys, is if I did the difference between the two centres, if I did the distance formula, what would I get?
Same answer.
I'd get 3 root 2. The only thing I need to keep you guys for is the hard part. The hard part being, how do you find out where the purple point is? Now here we go. We're going to do a ratio again. Okay. Now here's the ratio. Okay. What's the ratio of 4 root 2? Now it's actually harder than you think. How would you go from? Would you agree from blue to purple is how far?
5.
Sorry? Yeah, so from blue to purple is 4 root 2. From blue to red,
3 root 2.
3 root 2.
And the other's root 2, is it?
And the other one is? The other one would be just root 2 away. Now, the thing is, we know the two centres. We know that this one is minus, what's it, minus 2. And we know that this one here is 1, 0. Now, what we can investigate is, how do we get from there to there? 3 across and 3 up.
Yeah.
Now, would you agree that's a distance of 3 root 2 covered? That's 3 root 2 covered, yeah? Would you agree that from blue to red, that's 3 root 2?
Yeah.
And from red to purple, that's 1 root 2. That's a ratio of 3 is to 1. Okay? So look at this. 3 across and 3 up is the equivalent of moving 3. If that's 3, what's moving 1? 1 across and? So then all you have to do is this. 3 across 3 up takes you from minus 2 minus 3 to 1, 0. That's plus 3 plus 3.
Yeah.
Now all you have to do is plus 1 and
Oh, yeah.
plus 1, and I'll get to 2, 1. And you can see right there the external divisor is 2, 1. Okay, so for your homework tonight,